Okay. In this video, we're going to conduct an example of solving a substitution problem that has no fixed ingredients, meaning nothing is set in the ration. We are just going to be working with the available feeds. And the problem that we have today, which will also be posted in the upper corner as we're working through the problem, is a group of developing dairy heifers that are grazing some fresh, mature blue stem pastures. The owner has available to them bakery product as an energy feed, cottonseed meal as a protein source, dicalcium phosphate, and limestone for phosphorus and calcium, respectively. So the first step to any ration formulation problem is to gather information. So the problem actually tells us what these dairy heifers require. How many pounds of dry matter? How many pounds of TDN? How many pounds of protein, phosphorus, and calcium? I like to create a table like this one that has my requirements and my feeds all in the same area so that I am able to reference it fast and easy and not have to split up my work or break my rhythm as I'm working to look up feed information or anything like that. So what I did, and you can pause the video and copy this information down, but I have the feeds available, the blue stem pasture, the bakery product, cottonseed meal, dicalcium, and limestone. I indicate what categories they are: roughage, energy, protein, phosphorus, and calcium. And using my searchable feed table that I've created or whatever reference you have available to you, I looked up all of the corresponding feed information for this problem and recorded it so that I have gathered all my information into one location. Then we can start solving the problem. So I would encourage you to take a moment, work along with me, and jot down this table so that you have all the information that I'm going to be utilizing at your fingertips as well. Step 1, in which we have gathered our information. So we have the requirements for the animal. I'm going to abbreviate that, the requirements, and we have the nutrient composition of the feeds available, which are given to us in the problem. Okay, so we have all of our basic information that we need to solve this ration. So the first thing we need to do, because if we remember our food pyramid that we talked about, we need to check forage only. Does that meet the animal's needs? So we are going to check the dry matter, the TDN, the crude protein, phosphorus, and calcium coming from the blue stem only. So our first assumption is that the blue stem is supplying all of the animal's dry matter. So we have to transfer that information. So we are going to be assuming that the 17.42 pounds of dry matter required by these dairy heifers is coming from blue stem. Now, the secret to determining the amount of a nutrient we have to remember is the amount of a nutrient equals the pounds of nutrient or pounds of feed. Let me rephrase that. The pounds of feed times the nutrient concentration. So we have a weight times, in this case, everything is percentages, but some form of concentration. So we are going to take the data that we already collected, and we know that our blue stem supplies 50% TDN. So if we assume that all of our TDN is coming from the blue stem. What is the amount, the feed, 17.42, and I'm going to turn on my calculator, times 50. And we do that on a decimal form, and we find out that we have 8.71 pounds of TDN coming from the forage. Okay, so let's check for protein. So again, we know that we have 17.42 pounds of blue stem, and that blue stem, according to our chart, is 6% protein. So we multiply on the decimal form, and we get that we have 1.05, we'll round into the second decimal, pounds of crude protein. Okay, we're going to do the same for phosphorus, and what we discover is that we have 0.021, and for calcium, 0.070. Now, it's important to remember when multiplying by these decimals for the minerals, the decimal looks like it's moved, but it's not. These are very small percentages, under 1%. And so you still have to move the decimal 2 points to the left. That's going to be one of the most common errors in these types of problems when you're working with minerals. Okay, so now we know what is coming from our forage. This is what we call the supply. So now we're going to compare this to the requirement by taking the supply minus the requirement. And what I mean is that we know that the dry matter is correct. So we're going to take the supply, this 8.71, and subtract it from the required amount of TDN, 11.04. That gives us a negative 2.33 pounds. So is this forage supplying the TDN, the energy that these heifers need? No, there's a pretty large deficiency, and we'll talk about how big in just a minute. But let's check these other nutrients and just see where we're at. Okay, so we have the protein, we're getting 1.05, but we require 2.04. So just looking at this, it's going to be a deficiency again, but how much? Negative 0.99 pounds. Okay, so we're taking the supply, and this is the supply, minus the requirement here. The same for phosphorus, 0.021 minus 0.04. We are negative 0.019. Same for calcium, 0.07 minus 0.08. Negative 0.01. So what we've learned here, everything's deficient. Okay, so we definitely have a situation where the forage only is not supplying the nutrient needs of these dairy heifers. Now, I'm usually allow students that if we're within 5% of the requirement, we're pretty good shape. So let's check to see this energy deficiency. What percent of the required amount is it? So we're going to check the percent deficient. And I'm just going to do this for energy, because we know if it's over 5%, we got to fix it. This is where we take the amount deficient, the 2.33, divided by the requirement, which is 11.04 pounds of TDN. And we put that times 100. That's what gives us a percentage. So if I were putting that in the calculator, it'd be 2.33. We can do an absolute value, whether it's negative or not. We can just take the absolute value, divided by 11.04 times 100. And I'm just going to round to a whole number. This is really 21% deficiency in energy. That's big. We're 21% deficient in energy. We need to fix the energy. So let's fix energy. That is our next step. If you remember in the previous videos and the reading that goes along with this, if you're in my class, it's like a flow chart. Do we meet the needs? Yes or no? If no, then we have to fix that problem. And how we fix this is with a concept called net gain. And net gain is where if we have 1 pound of the blue stem and we have 1 pound, pretend these are of our bakery product, which is our energy feed, we know that in the blue stem, that half of this, 0.5 of that 1 pound, is TDN. In the bakery product, we know that 0.9 pounds is TDN. How do I know that? Because it's 50 and 90% respectively, but we're putting this on a per pound basis. Because what we're wanting to know is a 1 pound for 1 pound substitution. Okay, so if I replace 1 pound of bakery product into the 1 pound of blue stem, what am I really gaining? So what we call net gain, I'm going to change colors for a second, is actually this area right here, because the blue stem has some energy in it. So what net gain is the amounts per pound, the difference between the two. So net gain, I'm going to call that NG for right now, is 0.9, the new feed, the bakery product, the higher source, minus the forage source. And we always pull out of the forage because that gives us the most flexibility. And so our net gain, pound for pound, is 0.4 pounds or 0.4 pounds per every 1 pound of substitution. This is also the same as about a 40% gain. So when I replace 1 pound of blue stem with 1 pound of bakery product, I'm actually gaining about 40% of TDN. So now we can fix this because we know our deficiency is the 2.33 that we calculated earlier. Great. And remember that to fix something, we take the need divided by the concentration, and that's going to give us the pounds of feed needed to fix the problem. So we know the need. The net gain is our concentration. So that is 0.4. And what this tells us, oops, clear out, 2.33, is that we need 5.83 pounds of bakery product to fix the calorie deficit. Sweet. Let's double check that. So now we check it again. Did we fix? Because sometimes by adding in a new feed, we may be fixing other problems as well. We could be fixing all these other deficiencies. So we're going to check the blue stem and the bakery product. So dry matter wise, we know that these two need to total 17.42 pounds because that is what our heifers require. We know that we just solved for the bakery product to be 5.83 pounds. So now, through subtraction, we can deduce that the blue stem, the remaining dry matter, is coming from blue stem, 11.59. Quick check, do these two add up to 17.42? 9 plus 3 is 12, carry 1. 8 and a 6 is 14, carry 1, that's 7, 17. Okay, quick check, those work. We do the same for how many pounds of TDN, protein, phosphorus, and calcium are coming from each feed. So now we take these new amounts times the nutrient concentrations for both of those feeds, and we're going to add them up. So I'm going to work through that, and I'll put it at a little faster clip, but that way you can see what's going on. All right, so I have simply taken the amount of dry matter times the nutrient concentrations for both blue stem and the bakery product, multiplied it out to determine how many pounds of each nutrient is coming from each feed. So if we go back and we compare our supply minus the requirement, we are good on the dry matter. And if we take that 11.05 and we're comparing it to 11.04, we are actually meeting the needs of the animal. But now let's look here. We have 1.40 minus the amount of protein, 2.04. We're still negative 0.64 pounds of protein. That's pretty significant. And we're still deficient negative 0.01 pounds of phosphorus. And we're still deficient, oops, I didn't type that number in right. Happens all the time. 0 to 4 pounds of calcium. Okay, so this 0.64, how big of a deal is this? Let's clear the calculator. If we take 0.64 divided by the requirement times 100, it's a 31% deficiency. We got to fix it. So the next step, now that we fixed calories, those are good. Woohoo! Now we got to fix the protein requirement. Time to fix protein. So we're going to do the same concept. Now, this time for net gain, we're looking at the protein column. We've already added in the bakery product. So it's now a fixed ingredient. It will not change. It's staying because that fixes the calories. We're leaving it exactly where it's at. But now we're going to look at the comparison between the cottonseed meal at 48% and the protein of the blue stem at 6%. So if we were looking for the net gain in a pound for pound substitution, and we know it's the difference between on 1 pound of cottonseed meal, we'd have 0.48 pounds or 48% of one, minus 0.06 or how many pounds of protein is in 1 pound of blue stem. That difference is our net gain. And if we subtract that, we should get 0.42. So now, if we recall, our deficiency was 0.64. That's what we're fixing. 0.64 divided by 0.42 should be just over a pound, pound and a half. 1.52 pounds of cottonseed meal, the 41% kind is our description, to fix protein. Okay, so we figured out the net gain, the difference of 1 pound of cottonseed meal or the blue stem, the difference between the two, pound for pound. That's our net gain. Then we took the deficiency by the net gain or the concentration, and that gives us 1.52 pounds of cottonseed meal. Time to check our work. This is where the steps start repeating a lot. So we're going to have our blue stem and bakery product, because like I said, that's a fixed ingredient. And now we've just added cottonseed meal. We need to determine the pounds of dry matter of each, how much TDN, protein, phosphorus, and calcium is coming from each one. So we start with the bakery waste. That did not change. So I am actually going to pull over the numbers exactly the same because that is a fixed ingredient. Okay. Now we know that our cottonseed meal is 1.52 pounds. So we know, and we also know that the dry matter requirement is always equal to 17.42. That's what those heifers require. So 17.42 minus 5.83 minus 1.52. The remaining space is 10.07. So now we know how many pounds of dry matter is coming from each feed. We do the same thing we did before. Amount times the nutrient concentration to determine how many pounds of TDN, protein, phosphorus, and calcium are coming from now, not just 2 feeds, but 3 feeds. So this is again going to be the amounts times the corresponding nutrient concentrations from our data chart from step 1, gathering information. I'm just going to copy those, get those done, and fill in this table. All right, so now that we know how many pounds of TDN, protein, phosphorus, and calcium are coming across, it's again time to do the supply minus requirement. And if our supply meets or exceeds our requirement, we're going to be okay. These dairy heifers, if you remember, required 11.04 pounds. Okay. Here we've got a slight deficiency, even though we just solved for it, of a very small amount, 2.04, 2.03. If we check that 0.01 divided by 2.04, the requirement, that's less than 1% deficient. That's acceptable. That protein is resolved. Now we can move on. Now, if we compare the supply 0.047 minus 0.04, we find out that we've also met the phosphorus because cottonseed meal actually has quite a bit of phosphorus in it. So that helped us meet the phosphorus needs of these dairy heifers. But then if we check calcium, 0.053 is the supply minus 0.08. We are deficient, negative 0.027. Okay, so that seems really small. But remember, if we take that deficiency divided by the requirement, that's a 34% deficiency. And so even though that's a small amount, the requirement isn't very big. We have to fix calcium. But by doing that, that should be our last one. So time to fix calcium. All right, so we're going to look at our net gain. It's going to be the same thing. Now, so if we didn't fix phosphorus, we do not add dicalcium phosphate. We skip it because now we're going to go to our limestone source because we want to use what's going to be the most effective source of calcium. So limestone is 34%. On a decimal form, or in 1 pound of limestone, we'd have 0.34 pounds of calcium. minus, now this is where the number is making sure we move the decimal. The blue stem has 0.4% calcium. So we're actually subtracting 0.0040 because it's a very small amount for that blue stem. So we wind up with a pretty tiny number. Let me get to my right page here. That if we run 0.34 through minus 0.004, we get 0.336 as our net gain. So now we can take our deficiency, the 0.027 from right here, divide it by 0.336, and that's going to tell us how much limestone needs to be in these dairy heifers' diets. 0.08 pounds of limestone. So not a ton, very small amount, and that's why minerals are usually in pretty small quantities. You don't need a lot to fix an issue. So time to double check everything. So we're going to check again. We're going to be checking dry matter, TDN, crude protein, phosphorus, and calcium. And if you're noticing that while I'm doing these, I always keep every page in the same columns, just so I know. And then I fix the next ingredient, fix the next one. As I go, there's a system, there's a series of steps. So to make sure that you go through every part of the problem correctly. So we've got our blue stem, the bakery waste, which has not changed. We have our cottonseed meal, which is now also fixed and has not changed. And we're adding in limestone, 0.08 pounds to be exact. We know these need to equal 17.42. Cottonseed meal is fixed. Bakery waste is fixed. That leaves us with the 10.07. We can just subtract the new amount, the 0.08. That should give us 9.99 pounds of blue stem. If we add these up, let's do a quick double check. 0.83 plus 0.08. 17.42. Good. So now to figure out the amount of nutrients coming from each of these and totaling them up. Remember, bakery waste and cottonseed meal are fixed, so we can copy those straight across. We do have to calculate the blue stem and the limestone. I'm going to go ahead and do that for you. All right, so if we compare back to our requirements from the previous problem, good on dry matter, we exceed the TDN. We're good because we already know that is within 1% of the requirement. We exceed the phosphorus requirement, and we have now met the calcium requirement. So we have resolved the ration as of this point. The last step that we have to do is these are in pounds of dry matter. We just have to convert them to as fed. So blue stem, bakery product, cottonseed meal, and limestone. I'm just going to abbreviate them. We have pounds of dry matter, and we need pounds as fed. So just copying those across real quick. This is where we come back to our data sheet, and we need our dry matter percentages. And to add the water back in and convert from dry matter weight to as fed weight, we're dividing by the dry matter percentage. So this 9.99, almost 10 pounds of dry matter is actually 16.38 pounds as fed of the blue stem. The 5.83 pounds of dry matter from bakery product needs to be about 6.48 or 6.5 pounds. 0.52 divided by 0.9 for the cottonseed meal is 1.69 pounds. And the 0.08 divided by 0.98 isn't going to change a whole lot. It's still, if we round to 2 decimals, 0.08 pounds. The new as-fed amount that each heifer is going to be eating, 16.38 plus. So now you could actually take this and make it a formula on percentages. You could figure out how much per ton if you were mixing these 3 ingredients into something you wanted to give these heifers and supplement while grazing pasture. However you wanted to handle feeding them, you now have resolved what these dairy heifers need from these ingredients to be able to meet their dietary needs. Stay tuned for the next video, which will be an example of if we have a fixed ingredient from the beginning.